Alright, before I get to the actual lab, I just wanted to show you how I ended up setting up the top part of this, how they've got it there in the diagram. Grabbed the red cord that had the clips on it. That was from the Atwood's apparatus kit. That's the one that includes all the other materials that you'll need. I just took off one end of the clip, the other end still has it, and then I attached this onto this side. Taking this off is also what allows me to thread it up through the hole there. That was a bit tricky, so make sure you do that while it's off the stand before it's on the stand. This piece I actually had to go find in part of the ropes and pulleys kit. So find the ropes and pulleys kit, and there was a yellow rope with 2 of those on there, and so I just took one off to use for this. A little bit complicated, but I want to show you guys how I got all that set up, and now I will show you everything set up and we'll walk through the lab. Okay, investigation 4.2. As you can see from the setup, you've got a Photogate up top, Photogate down below. Photogate down below is the main one I believe that we'll be getting times for. And then from your, what was that, the Atwood's apparatus kit, you'll want that plastic piece, the bolt. You're going to use this black spacer. Hopefully you guys can see that. It's on the investigation sheet. This black spacer is what is going to pass through the laser. So we want to make sure that these are lined up. So it's that is blocking the laser light and setting off your Photogate. Similar to how the flag on the cars, you use that 1 centimeter to help calculate speed. You'll do the same thing using the distance from this. And so you'll have to talk to your kids. This is 2 centimeters. So the time that they get as this passes through, you have to do distance over time. So it'll be 2 centimeters divided by whatever time they got to calculate the speed. Now the instructions gives a lot of details to students about how they're going to be measuring the height as they pull this thing back. It talks about using like a paper sheet. I don't see why they just couldn't use one of these to pull back to 15. And then again, let one student do this roll so you can get good at making sure that it goes through. They're gonna have a lot of errors, and that's all right. But to be consistent, the investigation gives them the center of mass. Yeah, see, second try. But you wanna make sure that you have somebody stop the actual swing before it passes through, or else it's just gonna keep changing the time. So you'll swing it through once and somebody stop it. And that way you're not gonna mess up your times. You want somebody to hold on to that as they go through the different heights. So you'll just keep pulling this back, and now for 30 centimeters, I can measure it like this and get that time. Somebody else grabs it so it doesn't mess up our time. So that's pretty much it. They're gonna be calculating maximum velocities, which hopefully from the first part, they figure out that's gonna be at the bottom, and then we can convert from the potential height to the velocity, and you can make predictions and then calculations, and your potential energy that you've stored into it should equal your kinetic energy by the bottom of it. And so that's how it should work, and you should be good there. So pretty simple lab. The setup might be a little bit more work on your end, but once you got it set up, you're good for the day, and this walks them through every single part. And I talked about how to set that up correctly and where all the parts are. So hopefully that helps you with investigation 4.2.